Hi everyone, and welcome back to our new computer vision series. This is episode number 4. In this episode, we're going to continue working with OCR. More specifically, we're going to try and apply OCR to a video format and view our results. Being able to apply it to video will provide us another avenue of detection, and working with video formats will be very useful for computer vision in general. So we've already worked with PNG, JPEG, PDFs. Here, we're going to take a look at video formats. All right, before we begin, I also wanted to note something really quickly, and that is that I really appreciate your feedback on these videos. I always take it into consideration, and at times I might not be able to describe the code in a specific way, or I might become focused on one aspect of the code or algorithm. So if you have any questions about the code or the generally information that we're working with, or want some further information on specifics, please feel free to comment on the video, or you can even follow up with me on Twitter. I am new to the Twitter sphere, so I'll leave my name in a link on the video below. Okay, wrapping it up, your feedback is very appreciated and useful, and wanted to say thank you very quickly. Great, let's move on. Now, before we jump into the code, I wanted to have a little bit of a session to get you thinking here. And some of you are going to work with projects containing video, especially with OCR. And I want you to try and think, really, what do we need to work with video formats? What steps do you think are required, or how would you approach this problem? You have a video file and want to detect text within the video. Can you apply OCR to the video? The answer is yes. Yes, you can. And as always, there are multiple methods. We're going to focus on a standard approach that provides a few benefits for us. So let's jump into Spider and get started. We are back in Spider. And you will see I did clean up the file a little bit because the previous videos we were working on, we had all the following import statements. I did leave them in, but I removed the files just for now. The other samples from the previous videos are obtainable, so don't worry about that. But we need to add the following for this video. We will need to add the import statement OS, and you will need to install, if it's not already installed, OpenCV. You can use the following command that I left here, the conda install C, conda forge OpenCV, and if you want to take a look at the documentation for the installation with conda, you can use the following link here. I will leave them commented for you if you want to grab them from the file. Okay, so we're going to start working with our video file, and I just did a quick Google search for a video, so I have the test video MP4, and this is the following video that we're going to be looking at. As you can see here, I grabbed this video. You can hear some audio in it, but we're mainly concerned with detecting the text that you can see in the video. And that's what we're going for here with OCR. And if you've been thinking about how to do this, there are some methods. You can actually run this from the command line from the terminal. Once you get to a certain point, you can use Tesseract. We're using the PyTesseract wrapper, but you can use Tesseract to break down frames. There are quite a few shell and bash commands to work with Tesseract, but we're going to do a straightforward approach. And this is to actually take the video file and break it down frame by frame. The first step that we would need to do that after our import statements is we're going to create a directory for the frames. So let's add a note, bring in a little space. We want to create our directory for the frames for our video. That little space is going to bother me. I'm going to remove that. So we want to have, if not our OS path, if this doesn't exist, and let's call it image underscore frames. Let's create the directory. And again, we're using the same one, image underscore frames. And we're going to close that up here. So what we're doing here is essentially we're setting our directory. All right, we have resolved that. That error was between the different quotation marks. I just had to fix that very quickly. Now, you actually don't need to create the directory if you just want to save them within the folder that you're working with. But for organization, I would highly recommend creating an additional directory and folder to store the frames within it. And for our next step in this to work with the frames, we actually have to create the path to our video file to know what video that we're working with, how we're going to break down the frames. So let's call it our test vid, give it our name for our variable. We need to use OpenCV here, the video capture method, and our path to our test video, which is stored in the folder. So we only need the test video.mp4. Close that. Okay. Let me double check. Oh, there we go. We should be good to go there. Give ourselves some space here. I'll add a note as well to create our video path. Let's jump back down. And now we're going to start working with the main part of the algorithm here to break down the frames. And for this part, we really need to start with create an index or count. You'll see these terms used when you're working with OpenCV. So let's add another note to the part of this. Let's start our index or count for the frames. So we're going to assign our index equal to 0, and we're going to create a while loop. So while our test video, the file that we're working with, our test vid, is opened, we are going to use now, you're going to see ret and frame here. Frame basically is going to get the next frame in the camera via cap, and ret is going to obtain the return value from getting the camera frame. That's either usually true or false. You can check the OpenCV documentation for that, because there are a few tutorials that demonstrate the use of ret and frame. So we need to include these. We want ret and frame equal to our test vid. We need to read the file. And if we don't have it, we want to break. Okay? We also have to assign, I actually want to comment here, assign a name for our files, for our frames actually. I want to actually double check that. Okay, the error went away. We want to assign a name for our files as well. We're going to give it name equal to. We need to use our path that we're going to want to store the files in. Again, we're working with, we have our image frames. So we have our name equal to, we're going to open this, image frames slash, we want to give it a frame since we are working with it. Let's keep it kind of straightforward here. Close this, and we're going to create a index we're working with plus the PNG. Since we want to store in PNG files, sometimes PNGs are easier to work with, or not sometimes, most of the time they are easier to work with than JPEG. So we also want to create the essentially numbering each frame one by one. So let's give our string to our index and to create the .png. Now for the next part, you'll see that the code has been added here because I went and grabbed it so we didn't have to watch me type the remaining part of this code. So let's go through it. We want to assign our print statement. So when it's extracting frames, we can see this, the name of the frames created. We're using the OpenCV IMWrite function here with the name and frame parameters passed in and incrementing our index. Also, as a note, we're using the CV2 wait key. There are a few bugs with the CV2 wait key in the computer vision course on Udemy with the Super Data Science team. There was a few really interesting discussions with the CV2 wait key. Essentially, it's a hexadecimal constant representing 111111 in binary. And by using the bitwise and sign with the constant, it leaves the only last 8 bits of the original. So whatever the wait key is, we can use it. But due to the different systems here, sometimes the wait key has ran into a few bugs, so there is some experimentation. Now, upon running this, if this does go correctly, we're going to actually stop the process using the function here, or this option here, excuse me, because we want to stop the current command. Otherwise, it's going to keep incrementing and it's going to keep going because the wait key, when I was running my test, wasn't responsive. But that is the approach to break down the frames. Again, it's a very straightforward method, basically taking our video file, using OpenCV to extract each frame while it's open, printing it, storing it in a specific folder, and then releasing it if it was going to work with the wait key, but we're going to stop it since we really only need, for this video especially, since the video is a short little clip, we only need a few frames to test our OCR on. So let's run it and view our results. I'm going to go up here. And we have an error thrown. Okay, so I probably have a syntax error. And I believe it's because I did not capitalize key. Always a part of running this is debugging, so let's run it again. And here we go. It's creating our frames. As you see, it's printing each one, and it has the image frames here. So I'm going to stop this, and I really advise you guys to stop it as well, because it's going to continue to run. The wait key wasn't responsive, but you can test it out if you have it implemented. If you're able to stop it with the wait key or experiment with any other options, please feel free to let me know. I would be more than happy to take a look. But the main point is to extract these image frames. And we can take a look at the sample image frame here. We could take a look at the image frame here, basically breaking down the video into specific frames. All right. And since we have our frames, you can see I added another snippet of code that we have worked with. I'm going to comment this out so we don't have to run it again. Let's add that there. I'm going to start ourselves some space so we can visualize this a little easier. What we can now do is just process the frames. Now I'm going to take the first frame as an example. We're using our demo image open to open the frame, using PyTesseract, creating our image to string, and printing the text that's detected with OCR. And some of you may be interested, and I mentioned it earlier, other methods of batch processing. So if you want to go through the image frames entire folder, PyTesseract doesn't make it the easiest to do, but if you look into Tesseract with the bash shell commands, if you're working from a terminal, there are options. If you would like to discuss them further, feel free to comment on the video or reach out to me on Twitter. I'd be happy to share some resources if you're looking into experimenting further with the batch processing. So if you want to kind of iterate through the whole entire folder. But let's test our detection since we have returned our frames. That is kind of the majority of the work here. Once we have those files, we're really ready to apply OCR. So let's apply it. Let's run our little snippet of code here. I'm going to give it a second, and it should be returning OCR, the text detected from the frame. And there you have it. We have applied OCR to a video. Fantastic work. Great job working through everything. If you have any questions, ideas, or if you want to experiment with other video files and want to share your results, please feel free to comment on the video. Let's wrap it up here. As always, subscribe to the Super Data Science channel. It is an incredible way to stay up to date within the industry. Thanks again for spending the time to go through the video with me, and I will see you in the next one.